Algebra 2, this is target 29, adding and subtracting rational expressions. Today we are going to start just by focusing on adding and subtracting rational expressions that have like denominators. So if we continue to compare rational expressions back to rational numbers, aka fractions, when we're talking about adding and subtracting fractions with like denominators, for example, let's say I have 2 over 5 plus 1 over 5. Okay, and then adding those two fractions together, you just end up with the same denominator of 5, and then you just add the numerators together. So 2 plus 1, and that gives you 3 over 5. So we're going to be doing the same thing today, but just with rational expressions, where we have p of x divided by q of x. Alright, and we're just going to be adding those together. Okay, adding two of them together. Alright, so the key concept here for adding and subtracting like denominators is to add or subtract the rational expressions. Okay, you just simply add or subtract their numerators, then place the result over the common denominator. So if we have a, b, and c be expressions where c can't equal 0, then your addition property here is that a over c plus b over c is equal to a plus b over c. So again, you keep the same denominator, that common denominator, and you just add the numerators together. Same thing with subtraction. Okay, if you have a over c minus b over c, okay, then that's equal to a minus b over c. All right, so let's jump into some examples of this. First one we have is 7 over 4x plus 3 over 4x. So since we have the same denominator in each fraction, we can just add the two numerators together, 7 plus 3 over 4x. Okay, so that equals 10 over 4x. The only thing we need to be careful of now is that simplified? We always want to write our answers in simplest form. So 10 and 4 have a common factor of 2. So this is equal to 2 times 5 over 2 times 2x. So those 2's cancel out, and we're left with 5 over 2x. All right, next example. We've got, this one is subtracting 2x over x plus 6 minus 5 over x plus 6. So again, since the denominators are the same, right, we would just write the difference of the numerators, 2x minus 5, over that common denominator of x plus 6. And again, we want to look, can we simplify that? Well, 2x minus 5 and x plus 6 are both prime polynomials. Okay, there are no factors. So this would be your difference. All right, moving into the next example, 7 over 12x minus 5 over 12x. So again, you have the common denominator here, so you just take the numerators and subtract them, 7 minus 5 over 12x, which 7 minus 5 is 2. And then we look at, can I simplify that at all? Well, 2 and 12. Okay, both have factors of 2, so we can write this as 2 times 1 over 2 times 6x. Right, and again, the 2's cancel out then, and we're just left with 1 over 6x as that difference. All right, so pretty straightforward here. Again, you're just subtracting the numerators or adding the numerators, and then simplifying if possible. So let's have you try one. Okay, pause the video. Okay, give this one a try. When you're ready and you have your answer, then you can restart it. All right, so for this example, again, we have the same denominator, 3x squared. So we're just adding those numerators, 2 plus 1 over 3x squared. Okay, so 2 plus 1 is 3. And again, can we simplify that? Well, yes. 3 and 3 have a common factor. Well, they are the same. So we just cancel them out, and you're left with 1 over x squared. That would be your sum. All right, try this one. Okay, so again we have the same denominator, so we're going to just subtract those numerators, 4x minus x over x minus 2. All right, so 4x minus x is going to be 3x over x minus 2. And again, nothing we can do to simplify that. X minus 2 in the denominator, that's a prime polynomial, doesn't have any factors. All right, one final example. Okay, 2x squared over x squared plus 1 plus 2 over x squared plus 1. So again, give this a try. Pause the video when you're ready, restart it. All right, so again, same denominator, which means that we can just add those numerators together. So we got 2x squared plus 2 over x squared plus 1. Okay, we can factor that numerator. It has a 2 that can be factored out, so it's 2 times x squared plus 1 over x squared plus 1. So again, you have the same factor of x squared plus 1 there. Okay, and it's just 2 over 1, which is just 2. So that whole thing simplifies down to just 2. All right, that's the end of part 1. Okay, adding and subtracting rational expressions with like denominators.